So, having examined the periodicity of trigonometric functions like sin t, cos t, tan t, sin nt, cos nt, can we lay down certain general features of these periodic functions? We know that all trigonometric functions are periodic, but is there any general feature of these periodic functions? For example, we had seen that if a function like sin t, y is equal to sin t, it doesn't matter you write x is equal to sin t, y is equal to sin t has a time period t is equal to 2 pi, whereas y is equal to sin nt has a time period 2 pi by n. So if we correlate with the time period of sin t, this is equal to t by n, where t is this. We can see this. The time period of these two functions seem to be related in some manner. For example, if the time period of this is t, the time period of this is t by n. See, 2 pi by n. This function repeats after t by n. So what are the general features of such periodic function? It has been told that suppose y is a function of x to the power of n. If this function is periodic with a time period t, remember t is the period after which, or the interval after which the function has the same value. That means if I take t, whatever is the value of t, I get the same value for y if I substitute it for t or 2t or 3t or 4t or anything. So, for example, if this is the case, then you have certain interesting features. For example, if y is a function of x to the power of n is periodic, then you will find that a function such as x to the power of b to the power of n is also periodic. With the same periodicity t. If this is periodic, this will be periodic. Similarly, f ax plus or minus b to the power of n will also be periodic. But its periodicity will be equal to t by a, where t was the periodicity of x to the power of n. Look at the previous function, y is equal to sin t and y is equal to sin nt. We got the result here. Here n is equal to a, and we got the result t by a as the time period in this function. Here, if t was 2 pi, here t is equal to 2 pi by n, which is equal to t by n. That is this formula. This formula will also be periodic. So there are various combinations. In fact, there is another combination that if gx is a periodic function and hx is another periodic function, and the periodicity of gx is equal to t1 and that of hx is equal to t2, then agx, the function AGX plus BHX will also be periodic. With a time period that is LCM of T1 and T2. This is very interesting. If Gx is a periodic function, Hx is a periodic function, a combination of Gx and Hx such as A into Gx plus B into Hx will also turn out to be periodic, but will have a different kind of periodicity which is linked with the periodicity of the individual functions. It will be the LCM of T1 and T2. We'll see an example later on also how these periodicities differ. Now, having analyzed the periodic functions, we will come to what type of functions are called SHM, simple harmonic motion. In fact, simple harmonic motion is nothing but simple harmonic oscillations. But we will see what conditions are to be achieved if a body is to execute a simple harmonic motion. So, the next what I will describe is the requirements or the eligibility criteria for a body to execute simple harmonic